But an experiment will never tell you something like a function. An experiment will never tell you something like a law or something like this. What you're getting in an experiment are values. You're getting something like a table, x, y, and then you get some values. You will never directly observe a law, for example. Even if I go out to the balcony and throw one stone after another down to the street, I will never observe Newton's law. There is nothing to observe in Newton's law. I will observe times, for example. I can observe the height of the balcony. I can observe how long it took for the stone to fall down to the street. I can observe whether I met someone down there or not. But I will not observe Newton's law. I will not observe something like the distance is given by 1/2 gt squared. You cannot observe a law like this. You can find out afterwards, but you cannot observe it. What you're observing are values. And now the game in physics is to translate the values into functions or into a graph, and then to find out something, if there's something behind those values which is common to all values. If there is a connection between those two values, if I have a set of values x and I have a set of values y, and there is always a connection, and the connection and the connection and the connection and the connection is always the same, then I can say, well, the connection is my law. But I have to find out about that connection. And I don't see it just by taking a look on the values. And the normal way is now to translate the values out from the experiment into something like this. Here's my x, here's my y. Then you need to know if there is something like a connection between those values, and it's always the same connections. It's always the same connection. Where can I find that connection within the painting here? Where is it? In that case, it is here, the slope of the graph. So this is why there's a strong connection between drawing functions and finding out if there is any connection between the values you've got out of your experiment. So you need to deal with the problem table, graph, and translating one into each other. Either start here and end up here, or start here and end up with the law, or start here with your table and end up with a graph, or whatsoever. This is a whole package you need to know. B plus logarithm of a. Okay, it's just turned a and b. Now take the brackets here, then you have minus logarithm of b divided by a. So you can always write the logarithm of a divided by b is minus the logarithm of b divided by a. You can change the sign by changing the fraction here. So if this is an example, if you read in a textbook, for example, and you have an equation where there's a minus logarithm given, and in the next line the minus is disappeared, and you say, hey, where's the minus? It might be that you just change the fraction here, and this is why the minus has disappeared. Okay?